Hello, everyone. It's great to be here in San Francisco. It's a beautiful city. We are here today to talk about how we use Redis to leverage our business and how you can use Redis in your platforms and systems. But first, let me introduce myself. I am Luciano Sabenca. I'm a software engineer at Movile. I have been a developer for more than 6 years. I build highly scalable platforms for our systems, and I have a bachelor degree in computer science by University of Campinas, which is a pretty famous university in Brazil and one of the best universities in Latin America. And here with me is Eiti.
Hello everyone, I'm Eiti Kimura. I am IT coordinator and a software architect at Movile Brazil as well, and specialized to build scalable services to create applications that make difference in your life, right? And well, I'm talking about our use case in some conference around the world, and it's a pleasure to be back here in San Francisco. Feel free to follow me on Twitter, and I'll let me introduce you the company we work for. We work for Movile, and Movile is the company that make the applications that make difference in your life. We have applications that range from food delivery to kids entertainment. And Movile is a holding in Brazil and SMS and corporate messages broker as well. So from the companies of Movile Group, we work at Wave. Wave is the company that aims to connect your business to your clients through SMS messages and several different message channels as well, all right? We consider that it's important for you to understand our businesses, how our business work before move to our use case, all right? Let's give you one example of that. So imagine you receive a message like this. How many of you guys have received a message from your bank? It's pretty common, right? Yeah, a lot of people here. And all right, in any case of when you change your balance of your account, or when you go to an ATM or use your credit card, you'll be notified, all right? In this case, this account doesn't have too much money, right? Let's see, but things are getting better. You just receive a deposit, and you'll be notified about this deposit. This is one of our business of our company, but we have another business as well, which is the subscription services to our entertainment products, okay? And for our entertainment products, I will give you an example of the Play Kids. Play Kids, for those who doesn't know what it is, it's something similar to Netflix for kids, plus books, games, and entertainment. So kids just love this kind of thing, right? And in Brazil, you'll be able to subscribe to this service, this application, through SMS messages. In this case, you will start your subscription flow sending the keyword Play Kids, as you can see here, to a number. We will respond to you back with a message with the price of the product, requesting a confirmation, okay? After you reply with yes, we'll send you back a message with the link to download the application and the validation code. And then it's just to have fun. You have access to the premium content of the Play Kids. But you can try the free version of this application as well by downloading from your favorite app store, all right? Okay, we are here to show you how we use Redis to tie all of our services together to be able to create applications, fantastic applications like this.
This is our agenda today. We will show you 3 of our most successful use cases using Redis at Movile. And, well, let's start with a very, very brief introduction to Redis. We are at the Redis conference, so there is no need for a deep introduction to Redis. Redis is what's called a key value store, often referred to as NoSQL database. We will use it as NoSQL database. We use it as NoSQL database. It can handle concurrency problems very well, which is a very nice feature we use a lot. Records can be set to expire after some time, which is another very cool feature we use a lot. And it can be used in several different applications like this we will show you. And why we have chosen Redis? These are some reasons, okay, why we chosen Redis for our cases here. And, well, most Redis operations are atomic, which is great. There is no need for external synchronization. It's really nice. Redis async replication is fast. It makes Redis reliable. It's great for our cases. And all data sets in memory, so you don't have to access the disk to retrieve information. It's all in memory, all there. So it gives you a very low latency, which is great for our cases. And we have also data persistence, and that's great. We use data persistence in Redis to ensure durability of our data. So these are some of the reasons why we use Redis here. And let's start with our first use case.
Okay, let's get started with our use case presentation. And in our first use case, we are presenting you how we are using Redis as a database, as our primary database, and in fact, distributed database, okay? Let's take a look. Well, at Wave, we have a blacklist, right? Which is nothing more than a list containing more than 60 million records from our users, which requested not to be disturbed. By disturbed, I mean being charged, being subscribed, or receive any kind of message, all right? And we have more than 1 billion requests a month to the services, and it's a core part of our platforms, and that's why it should be really fast, with a latency under 5 milliseconds preferably. That's an example of how it can be used in our service layers.
Well, remember the example to subscribe to our Play Kids app? Let's see what's going on under the hood. So the user sends a message which will be received by our messaging platforms. And the message platforms checks the blacklist database layer to see if we can send messages to the user. Okay? If we can send message to the user, then we will ask for a confirmation. And if the user replies with an yes, we can build the user in our billing platforms, checking blacklist layer again. And we can move the user to our subscription platforms. Then the user is subscribed to the app, in this example, Play Kids, and he will be able to use the application. So let's see the entire flow here. As you can see here, blacklist database here, it's a crucial part of our business. It's a core part of our business. All our platforms depends on it, so latency is very important, fault tolerance is very important, and otherwise we will have serious problems. And let's see here. Well, remember when Eiti said 1 billion requests? That's where they are come from: web pages, mobile apps, marketplaces, third-party applications. All of these are using our subscription billing and messaging platforms, and all of these components are using the blacklist database layer. So it's a crucial part of our business, a core part of our business with high throughput and high volume of data. We tried different solutions to store a high volume of data. This solution is before using Redis. And in this solution, we had a traditional relational database, which generates a data file with the complete blacklist file with millions of records. And then this file was copied by our platform instance, and it was loaded in its local memory. So every platform instance has the complete head, in this case, the complete data set of the blacklist. Well, this solution worked fine for some time when we had few records in the blacklist, but we then expanded to other countries in Latin America, and the file grew to over 60 million records, causing these problems. a large amount of memory was being used with this solution. In our case, more than 5 gigabytes per platform instances. We use Java, and this caused the amount of memory being used caused a high frequency GC pauses, which caused general low performance. And we had scale limitations, so we needed to buy more memory for each platform instance. We will show you we are not running this platform instance in the cloud, so we really need to buy hardware for this platform's instance, and has costs and scale limitation, okay? We had to change it. This was affecting our throughput, our business, our customer experience. We had to change this architecture, and, well, Redis came to rescue in our case. This is our new architecture. We are using here Redis as our main database here. So all the blacklist data is stored at Redis right now. So here Redis acting as a main database. We generate a small Bloom filter file, which is loaded by the platform instances. And the Bloom filter filters most part of the requests, and only a small part of it goes to Redis. In this architecture, we don't need to load a very big file. We only load a small Bloom filter file with around 100 megabytes. Before we were loading 5 gigabytes of data, which is a huge difference. So with this solution, we have a very low latency due to Redis, and we also don't have more problems. We don't have more problems about memory consumption or high frequency GC pause. We don't have problem anymore with throughput here because we are only loading a small Bloom filter file. Well, and why we use Redis here? What are the advantages of Redis for this new architecture? Well, we see these 3 advantages of using Redis here. Redis provides a configurable persistence, so the data is persisted at Redis, and it's great. It acts as a real database, as our primary database for the solution. We also have configurable replication strategy, which is great. We can deal with failures in a much more better way than before. We have persistence. I will show you our infrastructure. So we have configurable persistence. Redis has this, and it's great. And we also have fast in-memory data access, which is great. We need low latency, and Redis provides us low latency. So Redis, for this use case, it's a really, really good match. And, well, this is our infrastructure architecture here. We have 2 data centers in Brazil, in 2 different cities. And we have 2 Redis clusters in master-slave mode. It's not a really Redis cluster, it's just a master-slave. And our application writes to both Redis nodes, Redis masters in our case, and we read from the closest node, okay? So if an application running in data center 1, it writes to both DC, but really only from the Redis in the data center 1 here. We can survive up to 1 instance down for each DC, and to lose the data, we will need 4 instances corrupted, because all of these instances are persistent at disk. And we will need the 4 corrupted, which is very unlikely to happen. They are in different DCs, so that's great for us. We have persistence here and durability of the data. These are the results we achieved with this solution. Redis allows us to achieve these results. We have a higher message throughput than before, a higher scalability than before, with lower costs and lower latency and business impact. We saved more than 100 gigabytes in memory, comparing with the previous solutions. We saved $1,000 in memory also, and now we have distributed data reliability, right? In this case, Redis is our main database, and it works very well. It works fine for the case. It allows us to do these results here. Well, let's see our second use case.
Okay, but before moving to the second use case, did you notice in this first use case that with a small change in our architecture, using the Bloom filter and using a very fast database, which is Redis in this case, we were able to save a lot of hardware resources, money, and especially our scale, the problem related with scalability, all right? Which is great in this case. But now in our second use case, we'll show you how we are using Redis as a cache in our services. Let's take a look. Okay, as you know, one of the most common usages of Redis is as a cache. Okay, in our case, we are caching more than 160 million records of our users, and it's pretty much essential for our platforms, especially impacting our subscription flow to acquire new products, and it has direct impact in revenue as well, of course. But what the data we are caching here? That's an important question to do. We are caching here a gray list. But what is the gray list concept? Let me show you here. So gray list is a list that we are ranking our users based on their payment history and the products they were subscribed in the past. Then we compute a score. As you can see here, we have the phone numbers of our users and the computed score. And we'll only subscribe users with some acceptable score. And you can configure that by product. And we are doing that to filter some bad users, bad media partners, and so on. Basically, the direct impact in our revenues is related to save money doing that, all right? Let's see an example of how it works in practice.
To better understand the concept of gray list, let's imagine that you are being impacted by one of our media partners. You will receive a message like this. Would you like to subscribe to Sport News? Well, let's imagine that you answer with yes. So this will trigger our subscription flow, which consults the gray list service layer. And the gray list service layers consults Redis and obtains the score from the user in the Redis. We will check this score against some rules. Like in this example, we have two possibilities here. Or the user doesn't have an acceptable score, and we won't subscribe the user. Or the user has an acceptable score and will be able to use the product, we will subscribe the user. Let's imagine that the user doesn't have an acceptable score in this example. So here is the answer, sorry, we are unable to subscribe you to the product. Well, let's see the entire flow altogether here. This is the entire flow. As you can see here, gray list is a core part of the flow. So it must be super faster, or else it can affect the user experience when acquiring a new product or service. And it causes the active revenue losses, a bad user experience. The user doesn't subscribe to the product, resulting in revenue losses, right? So here, Redis is very good because Redis is very fast. So it doesn't affect the user experience when acquiring a product or service, right? But how do we process this data? This is our solution to process the data. We generate the score daily, and we persist it at the cloud, at Amazon Redshift. So all the data is at Redshift. And then we export the data to a distributed file system. In our case, Amazon S3. And then we use Apache Spark to parallelize the load up of the data into Redis. So we load the data into Redis using Apache Spark. Well, with this architecture, we can process a high volume of data in just a few minutes with a very high throughput. We don't need the data persisted to Redis, and we have disabled Redis persistence. We disable Redis persistence, we reached a very high throughput in just a single instance. We are using a single Redis instance here. We have some peaks of writes around 400,000 writes per second, which is great for a single Redis instance. And this is the graph showing the Apache Spark execution job, the writing process into Redis. So this is the write rate in seconds doing the Apache Spark execution job. As you can see here, we process that amount of data in around 10 minutes or a little more, I think, which is great. We are talking about a huge volume of data. And even with this write rate, Redis response is below millisecond, which is great for our case. We have no impact at all in our subscription flow. The user doesn't notice that there is one more service during the subscription process, right? So that's great. We have disabled Redis persistence because here we are using Redis as a cache. So these are some of the results we achieved with this gray list solution using Redis, powered by Readies. We blocked more than 1 million subscriptions from bad payers users, which is a very huge number. We saved around $6,000 in media in just a few months. We are running this solution in just a few months, so it's a very high amount of money in just a few months. And we have a block rate over 40% for some campaigns, which means that these campaigns were not reaching good users. So it's not really good campaigns, it's good media campaigns. So we had to change these campaigns and think about it and save some money from these media partners, right? So here is the end of our second use case, Redis as a cache. Here, Redis doesn't persist the data. The data is stored at other place. Redis just cache the data, right? And let's see our third use case and most different use case of Redis.
Okay, but the results of the second use case are great as well, you know, because with a simple cache, we were able to filter low performance media partners and users with direct impact and positive impact in our revenue, which was pretty great. And the Readies was running really fast to our needs. All right, that's our third use case. Guys, you remember the title of this presentation, which is the versatility of Redis, okay? And the best example of that is this third use case. So have you tried to orchestrate a distributed system using Redis? We tried and it works. Let us show you how we do that. In this case, we are handling a pool of SMPP connection. Remember our SMS business that we show you? We are connecting our platforms to the mobile carriers using SMPP protocol, which is an industry standard protocol to send the messages, okay? And we have some particular characteristics, like it's a stateful connections, and we have a limited number of binds that we can bind to these connections. The connections can be shared between the platform instances as well. And what makes this use case different from a traditional orchestrator of a distributed system is that we should be able to load balance these connections through our platform instances. Okay? Let me show you an example of how it works.
Well, this is the normal scenario, the perfect world scenario. We have two platform instances connecting to the carrier, to a mobile carrier, using SMPP connections and using two different SMPP connections. These connections are really different. They have different parameters, different states. They are really different. And in this example, they are to the same carrier, but it would be two different carriers. Okay? So this is the perfect world scenario, but do we live in a perfect world? No, we do not live in a perfect world, and this is a failure scenario, right? In this scenario, one platform instance is down for any reason, maybe a bad deploy, or the instance goes down there are a couple of reasons to the instance might get down. And well, we basically lost the connection in a failure scenario here, right? This connection is idle. It's not being used by anyone. And what does it mean, the connection being idle? The connection being idle means that we won't be able to send messages in the throughput we need, okay? This might cause problems with the user experience to send messages to our platforms, and it might cause problems in the mobile carrier side also. And, well, it's bad for everyone. It's bad for us because we have a idle connection here, and it's bad for the customer. It's bad for the mobile carrier, right? And what we expect to happen here is this scenario, is the expected scenario. What we expected to happen when a platform goes down is that the remaining platform will be able to reestablish the connection that was with the platform that went down, right? And this would not happen without an orchestrator, and we have decided to use Readies to do this, right? And this is the solution we got here. Here, Readies is responsible for keeping all the states related with the connection, right? So how many binds are available, how many connections are idle, and how many platform instances. All this information is stored at Readies. And Readies is also responsible for doing the lock. So only one platform instance will have the lock for that connection, right? So we don't cause conflict between the platform instance here. And let's see in more details how we use Readies here. This is another diagram showing how we use Readies. We currently use a single Readies instance, and that might cause some problems, like we will talk about these problems in the end of the presentation, but it works fine for us, and that's great. We created a lock control component here in this diagram, which always keeps trying to acquire a lock. So we always keep trying to acquire a lock to Readies. When the component acquires a lock which is available, it notifies the platform instance, and the platform instance uses that resource. In our case, the resource is the SMPP connection. So when the platform instance is notified that they have that connection, they connect to the carrier and can send message to this connection, right? But how do you set and release the lock? It's a very simple Readies command. Readies has this feature, right? Which is the usual set command with the resource lock name being the connection name in our case. And we use also some random value to ensure who is the owner of the lock, right? We use also two flags to the set command, which is the NX flag, which indicates that I will only set the key if the key does not exist yet. So this is what basically does the lock, right? This NX flag. And we use also the PX flag to set the expiration. So the lock will expire if not renew, all right? So it is important if the lock owner goes down, the lock will be available again after some time. And to release the lock, we use another very cool feature of Readies, which is the possibility to execute a Lua script. So we execute this Lua script in Readies. So this is a very basic Lua script, which only checks if I am the owner of the lock. So to prove that I am the owner of the lock, I must use that random value that I set as the lock value. And if I am the owner of the lock, I simply delete the lock, and the lock will be available to other platform to get that lock. If I'm not the owner of the lock, I do nothing because, well, I'm not the owner of the lock and cannot release something that I'm not the owner, right? And that's great. It's a very cool feature of Readies, the possibility to execute a Lua script. You can check the source of this code and a lot of information at Readies official documentation. Readies official documentation is great. There are a lot of examples and more complex solutions to these problems. But right now we use this solution, which is very simple and it works very nice for us, right? And why we use Readies here? I mean, there are other orchestrators, distributed system orchestrators, but we use Redis. Why? We see two really great properties of Redis to this solution, which are atomic operations. So as we said before, most Redis operations are atomic, which is great. So we don't need to worry about external synchronization. We don't need to worry about race conditions. We don't need to worry about inconsistency lock. The operations are atomic. It's great. But that's not all. Another very important feature of Redis is its powerful data structures. So Redis provides us very powerful data structure, which allows us to implement the load balance that Eiti said that we would need. So we would not be able to do the load balance between the living platforms without the powerful data structures that Redis provides us, right? So Redis is a really good match here. These two properties makes Redis really nice for that use case, and it works very nice for us, right? So let's see the results. We have increased our reliability for our integrations, and we increased our resilience to failures in our systems. So it's a great result. We have a lower downtime for a connection, which is great also. So we provide a better user experience to our customers and to the carrier, and for our own reliability, which is great, right? And using Redis as an orchestrator here. Well, let's see some lessons we have learned using Redis in production for these three use cases.
So yeah, okay. With this third use case, we don't need to worry about if one of our instances goes down, because with our component backed by Redis, we are able to ensure that all of our connection resources are being used properly, okay? Affecting, of course, the overall availability of the platform. But after this use case, we have some lessons learned to share with you as well. So the first one from our first use case, remember when we show you our infrastructure architecture with two data centers, we are running here two data centers with master-slave mode, all right? The clusters doesn't know the existence of each other. So that's why we had that replication are being at application level. We have to replicate data by ourselves. Okay, we can live with that. But imagine if you have more clusters in some other different data centers. This solution will be kind of hard to implement and maintain, because in case of a network failure, for example, if you write a failure to a data center, you have some different number of keys in your data centers in general inconsistency. We had to write a software to synchronize these data centers to make it more consistent. Just keep in mind that this kind of solution has some drawbacks, okay? All right, and when the problem comes to the latency to access the information, we have it here for a matter of comparison, the number to access data from the memory, to send a bunch of bytes over a network, and to read data from a disk. And it's evident that read data from the memory is much faster than the other options. And that's why in the second use case, we disable Redis persistence, okay? Because in our second use case, it's just a cache, okay? If we lose data, we can load up the data from our database to the cache, and everything's gonna be fine. Perfect. But we have some configuration mistake we did in our infrastructure architecture that is worth to share with you.
Well, this is our architecture in a little bit more details for the first use case. And well, we tried a solution that didn't work to improve Redis resilience, right? We learned a tough lesson here. We will explain in more details here. But what's important that is we use a daemon, keep alive D. It's a daemon which checks if an instance is alive, right? And we connected to the master of this Redis master slave using a virtual IP which always points to the master. So the virtual IP always points to the master, and our platform instance connected to the Redis cluster through this virtual IP, right? So all the writes goes through the virtual IP to the master in this solution. And what we expect to happen here when a master fails? This is what we expect to happen here when a master fails. Well, keep alive D is supposed to detect the failure, and it must promote the slave to master, and we should able to change the virtual IP. It should be able to change the virtual IP to point to the recently promoted master, as in this diagram, right? So this is the complete failure expected scenario. So that master failed. The slave was promoted to master. Keep alive D detect that failure, promoted the slave to master. The virtual IP points to the master, and when the old master comes back, it comes back as a slave, right? And all should be fine because Redis will sync this old data set using the most updated master data set. Right. This is the expected scenario. For the platform instance, nothing happened here, just the connections are dropped, and I reconnect. Okay, no big deal here, right? But guess what? That's not really what really happened here well, life's full of surprise. And what happened in production one day was this, right? So what happened is that some part of the solution worked, and some part didn't work. And well, when the failed master came back, it came back not as a slave as expected, it came back as master. So the recently promoted master was downgraded again to a slave, and the virtual IP points to this old master that went back. And this was really bad because this master had stale data, and well, in constants, we basically lost all the writes that happened during the period that the master was down, because it started to synchronize its data, its stale data, to the slave most updated data. So this was really bad, right? Because we lost a huge amount of data. We had an overall consistency problem in production, and we learned, we learned a lesson here, right? We learned a very tough lesson, but we learned a lesson, which is don't try to reinvent the wheel. Don't use Rome-made solutions. Redis provides us a fault tolerance, a solution to a failure, which is Redis Sentinel. Use it. Don't try to use other solutions. It won't probably work, right? And we learned that lesson, and we started to use Redis Sentinel instead to try to build our solution. And well, let's see the last lesson we learned.
Okay, guys, just to reinforce, don't do that, right? that we tried. Just completely failed, and we started to synchronize stale data over your cluster to all of our slaves, and you feel it's kind of big trouble. It was a mess to fix that, okay? Okay, and another lesson for our third use case. Remember when you had the scenario of our platform instances trying to acquire a lock, and Redis is the main component controlling the lock of the distributed systems. And in this case, so we have a single point of failure because we just have only one instance of Redis taking care of all of these concurrent connections. All right. In our case, for our solution, it's completely acceptable. We can survive with some unavailability for a while, all right? But consider before using this kind of solution if your business, your system requirements are able to survive with some problems like that in case of a failure. And we have another point as well, which is that solution may be not very suitable for a high throughput lock, okay? Because we have data propagation over our cluster. Right, we have a delay when you write to the master and start to propagate to other nodes. That may have a network delay. You can deploy your cluster in different regions, different data centers. It can take a while to synchronize all data in the locks, so this may be a problem. And in this case, if you have a more complex solution, consider to use the red lock algorithm. We didn't use that because we have the requirement to implement a load balancer together with our lock control. That's why we didn't use that. It's a much simpler solution that we have at our side. Okay. All right, and with that, we come to the end of our presentation. We'd like to thank you all. Thank the Readies conference for this opportunity. We will be here all day long. Feel free to talk and ask any questions. Thank you.